So you're obviously aware of probability from GCSE, so this is going to be a very short video. I just want to go through some of the basic probability questions they could ask you in Year 1, Chapter 5 in the textbook. We're going to go through Venn diagrams and tree diagrams in the next few videos, okay? So here's an example question that they could ask you, where we're told the grouped frequency table below, which is this here, shows the time taken for customers to receive their food at a restaurant after ordering. And we need to find the probability that a customer had to wait more than 30 minutes to receive their food, okay? So we can see that we have 30 minutes here. So these two intervals here are all of the times that are more than 30 minutes, okay? So we have this 9 and 2 here. So if we do 9 plus 2, this is equal to 11. So this is the number of customers that had to wait more than 30 minutes. So therefore what we're going to do, this number here, we're going to divide this by the total number of customers in order to get the probability, okay? So if we add all of these frequencies together, so it's 7 plus 12 plus 15 plus 9 plus 2. If you put this into your calculator, this is equal to 45. So the probability that a customer had to wait more than 30 minutes is 11 divided by the total number of customers, which is 45, okay? You can leave it as this fraction here. If you wanted to put it into a decimal though, it's equal to 3 decimal places, 0.244. Okay, so here's another example question that I've slightly adapted from a past paper question. So we're told a medical researcher is studying the number of hours, which is T, a patient stays in hospital following a particular operation, okay? And the histogram below, which is this here, summarizes the results for a random sample of 90 patients, okay? And using the histogram, for part A for 2 marks, we need to find the probability that T is bigger than 20, okay? So we did a video on histograms in Year 1 of Chapter 3, so go back to that video if you need a reminder of how we approach these questions. Whenever you're given a histogram like this here, what you first need to do is find the value of K. So this is the scaling factor between the area under the histogram and the number of patients, the frequency, okay? So we need to find the total area under the histogram first for this question. So the way that we're going to do this, so let's start with this bar here. So it starts at 0 and then this here is going to be 4 on the x-axis. So the width is 4 and this is multiplied by the height, which comes up to here, which is 2.5. So 4 times 2.5 is 10. So this bar has an area of 10. If we look at this bar here, it starts at 4 and it ends here at 7. So it's between 4 and 7. So it's going to have a width of 3. And this is multiplied by the height, which is also 3. So 3 times 3 is 9. So this is the area of this bar here. If you look at this bar, so it starts at 7 and it ends here, which is 12. So the width is between 7 and 12, so the width is 5, and this is multiplied by the height, and this on the y-axis comes up to 4.2. So 5 times 4.2 is equal to 21. If you look at this bar here, it starts at 12 and it ends here at 16. So the width here between 12 and 16 is going to be 4, and this is multiplied by the height and it comes up to 4 as well. So 4 times 4 is 16, like this here. This bar starts at 16 and ends at 20, so the width is going to be 4, and this is multiplied by the height, which comes up to 3.5, and this is 14. So this is the area of this bar. Then this bar here is between 20 and 40, so the width of this bar is 20, and this is multiplied by the height, which is 1. So 20 times 1 is equal to 20. So the area of this bar here is 20. So if we add all of these areas together, so it's 10 plus 9 plus 21 plus 16 plus 14 plus 20. If we add all of these areas together, it's equal to 90, which is the number of patients. So this is one of the nicer examples where the area under the histogram is equal to the frequency. In other words, K is equal to 1. You still need to make this check though, because that might not always be the case. So therefore we can use this going forward in the question. Okay, so we need to find the probability that t is bigger than 20. So on the x-axis, 20 is here. So we're interested in this area above 20, which is represented by this bar here, which we know has an area of 20. Okay, as you've already talked about in this particular example, the area under the histogram is equal to the frequency. So this here is the frequency for when t is bigger than 20. Okay, so to find the probability, we need to divide this by the total frequency, which we know is 90. So 20 divided by 90 as a fraction is 2 over 9. So this is the probability, or if you want to write it as a decimal, this is 0.222. So this here is the probability that t is bigger than 20. Okay, and then for part B, we need to estimate the probability that t is bigger than 10 but less than 30. Now, we went through questions like this in the histogram exams question video, so go back to that if you need a reminder. When we're estimating values using a histogram, we essentially create our own bars. So what we're going to say, so we need to find when t is bigger than 10. Now, 10 is here on the x-axis, so we're going to draw a line up like this here, and then t needs to be less than 30. Now 30 is here on the x-axis, so we're going to draw a line like this here. So we need to find the frequency and the area under the histogram between this line and this line here. Okay, so the way that we're going to do this is, so firstly we're going to consider this green bar here, and we're going to find the area of it. So the width of it, so it starts at 10 and it ends at 12, so the width is 2, and this is multiplied by the height, which is 4.2. So if you put this into a calculator, this is 8.4. So the area of this bar here is 8.4. We know the area of this bar here is 16, we know the area of this bar is 14, and now we're going to consider the area of this green bar here. So it has a width between 20 and 30, so it has a width of 10, and this is multiplied by the height, which is 1, and 10 times 1 is 10. So the area of this bar here is 10. So therefore the area between 10 and 30 is the area of this bar, which is 8.4, plus the area of these two bars here, which are 16 and 14, and then the area of this bar here, which is 10. Okay, now we need to find the probability, so we need to divide this by the total frequency, which is 90. Okay, so we're going to do this divided by 90, and if you put this into your calculator here, it's equal to 121 over 225, or if you want to express this as a decimal to 3 decimal places, it's 0.538. So this is an estimate for the probability between 10 and 30.